All right, 10.7, inscribed and circumscribed polygons. Now, inscribed, a polygon is inscribed in a circle if all of its vertices lie on the circle. So in this diagram right here, this triangle is inscribed. The circle, all the vertices are on the circle. I always think inscribed inside. A polygon is circumscribed about a circle if each of its sides is tangent to a circle. So this second diagram here that I starred in blue, that polygon is circumscribed about a circle. You could also describe the circle being inscribed or circumscribed. So the first diagram with the red star, the circle is circumscribed. The center, here it says, the center of a circle circumscribed about a polygon is the circumcenter. So this would be the circumcenter. And this is the circle circumscribed about this triangle. We'll just put that in words there. So circle, circumscribed about triangle ABC. And then here the circle is inscribed in the, we'll just call it the polygon TSRQP, and this is then called the incenter. So it says, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that would mean, let's mark them here, the same color doesn't mean congruent, but supplementary. So angle A is supplementary to angle C, and angle B is supplementary to angle D. And it makes sense because let's just take angle B and D, for example. They're where they intercept the circle, like angle D here intercepts the circle at A and C, and angle B intercepts the circle at the same points A and C. And so combined, they intercept the whole circle, which is 360 degrees. And remember, the angle is equal to half the arc. So the sum of the two arcs is 360, which means the sum of the angles is 180. Next, we have if a parallelogram. So notice this is in the previous example, it was quadrilateral. So here we have if a parallelogram is inscribed in a circle, then it must be a rectangle. So when we have the quadrilateral inscribed in a circle, the opposite angles are supplementary. But a little more specific, if it's a parallelogram, it has to be a rectangle. And here's basically the proof, right? Let's just read through it together. If ABCD is an inscribed parallelogram, then BD, these two diagonals, are diameters. And so if those are diameters, and O is the center of the circle, all of these are radii, right? And then they make, let's see, AB squared plus BC squared equals, yes. So what I was going to say was, I was thinking they were talking about the middle angles. So because that's a diameter, this is 180 degrees, which makes this 90 degrees, right? And that's the same for all of them. So it makes all of them 90 degrees. It kind of goes with the previous, but even more so because it is inscribed in a semicircle. Each of those triangles is inscribed in a semicircle. They would all be right angles, which would then make that parallelogram a rectangle. Next, we have a proof to do. So let's take a look at this. It says, given quadrilateral, ABCD is inscribed in circle O. prove angle B is congruent to angle ADE. So we want to prove these two are congruent. Well, let's do this. Statements, reasons. So 1, quadrilateral ABCD inscribed in circle O, given. All right, so now what do we know? What do we know? Well, we do know that when we have a quadrilateral inscribed in a circle, that the opposite angles are supplementary. So we could say something about all the opposite angles, but since we want to know about B and ADE eventually, let's just talk about these. So we know that angle, we'll just call it angle B, is supplementary to angle ADC. And like I said, quadrilateral inscribed in a circle, then opposite angles supplementary. All right, well, we also know these two angles here make a linear pair and are supplementary. So we could say angle ADC and angle ADE are supplementary. And that's because linear pair is supplementary. And so we can then say angle, since angle B and angle ADE are both supplementary to the same angle, we can say angle B is congruent to angle ADE, and that would be supplements of same angle are congruent. There we go. Finally, it says parallelogram. So now we have parallelogram. Parallelogram, ABCD is inscribed in a circle, and its diagonals intersect at E. Draw the figure. All right, so let's, what do we start with? Try to draw this the best we can. Oh, that's not even cooperating. Let's see. Come on, circle. Why is it not, why is my trick not working? There we go. All right, so we have our circle. Now, if it's a parallelogram inscribed in a circle, we already learned that that is a rectangle. So let's, oh, come on. I wanted you to work. Why is my trick not working? Come on. Oh, one more time. All right, I'm going to take it out of here. Whoops. I'm like you kids now. I want my trick to work. There we go. So let's move that. Look at me. Look at me do that. I'm so proud of myself. All right. Oops. Well, should have made it a little bigger, but oh well. You get the idea. So there we go. And then now let's draw in its diagonals. And they intersect at E. And this is parallelogram A, B, C, D. Remember, those vertices are touching the circle. Okay, so that was A. We drew the figure. B, what is true about ABCD parallelogram? And that it is a rectangle, and we know that. What is BD? Well, BD is a diameter of the circle, right? And it's also a diagonal of rectangle ABCD. And finally, D says if AB is 5, BC is 6, find AC. Well, we know this is a rectangle, so this is just a matter of 5 squared plus 6 squared equals AC squared. And you should find out, well, let's just do it. 25 plus 36 equals AC squared. AC squared equals 61. And that's where it ends. So AC is the square root of 61. And there you go.